Because it's open source, they don't have to tell us. And the licensing terms on Zephyr are Apache 2. You should give us some credit that's license terms, but realistically, finding them is a bit of a discovery zone. And so it's a detective game. I love when I learn about a new product.
You need to give something back. And that commercial success that you are looking for is enabled by all of those open source technologies. So if you don't have this civic reflex of giving back in one way, then you're missing out.
When we talk about more and more functionality in the software and moving away from the mechanical parts, you want to make sure that the software is running correctly, and that's where you have pretty much all the devices in automotive these days having a particular ASIL level. We call it ASIL level because of the criticality. We have different kinds of devices in the market as well.
Welcome to Forging the Future, and I'm here today in Austin, Texas at Embedded World. First time it's been in North America. I'm sitting here today with Kate Stewart, who is the VP of Dependable Embedded Systems for the Linux Foundation. Thanks for coming on.
Thank you. I've been looking forward to this.
I love your title. What's behind that?
Basically, when I started working at the Linux Foundation, I was one of the few people who could work on embedded. So they were pointing embedded projects to me to help, nurture and, coax. And one of the big challenges is making sure, especially in embedded, that we actually have things being dependable. And so when I got the VP promotion, it was a question of, okay, what do you want your title to be? I went, well, I want dependable there because we need maintainability, we need reliability, we need to have safety, we need to have security. And some of these things are afterthoughts. And I think we need to be raising the profile of them. And so I've been working on with the Linux, with Zephyr, with other projects, how do we actually make sure we can get these things being more front and center and the right level of analysis can happen so people can stay safe.
Well, when did Embedded Linux become a thing then?
Oh, Embedded Linux has been around pretty much since the start of Linux.
Okay.
Pretty close to it. Linux has been about 60% of the embedded market is running on Linux, is our estimates, our best estimates at this. It's hard to get good data, but Linux pretty much dominates, as the underlying infrastructure for most things. And like I say, embedded, there's a lot of proprietary still, and there was a lot of roll your own. There was an awful lot of roll your own that was out there. The trouble is, when we started the Zephyr project, for instance, the big joke was, what's the S in IoT, right? Mm-hmm. And at that point in time, it was a question of, well, actually, let's see if we can figure out how we can do things when Linux is too big. How can we come up with something where we can do security properly?
S being security, right, for the folks at home?
Yeah, S being for security.
Yeah.
S is definitely security. Although I could say S is now for safety, too.
That's true. That's important.
And it was interesting that I learned that it's the same word in German, which is sort of interesting as well.
Oh.
But anyhow, for this security
Those
side.
Germans, they have a word for everything.
I know they do, don't they? But so looking at, we did a study group before we launched the project to try to figure out, well, what were the pain points in the embedded industry? And safety and security were the clear pain points. And so the question is, how can we do this out in the open in a way that everyone can benefit and we can build off of it? And so literally we launched the Zephyr project at Embedded World in Nuremberg in 2016. And that same week, we had our first security meeting. So we focused on trying to get our security profile and figure out best practices for security and working it forward from that perspective. And, we've taken a lot of steps with the project in that way. Whenever we found a new best practice, we try to apply it. So like there was the CII badging program that was, and now it's under OpenSSF, which is a best practices badge. We were passing it within the first 6 months of it opening. And then we went up to gold, and then they added more criteria, and we went and met it. And so everything is publicly documented, it's visible, you can minimize your risk. Those are the sorts of things we were looking at. And so there was things that were doing it for security, but the safety side of it's just now starting to, we're figuring out some paths where we can use the infrastructure and sharing, because most of the safety stuff had been happening under NDAs. and happening with proprietary RTOSes and happening with proprietary apps. And the challenge is safety is a system. It isn't a component.
So why was it happening under the?
Because there is
proprietary?
risks of, and because if you do something wrong, someone can come and sue you.
Okay.
You'll notice that the automobile manufacturers are very concerned about these types of areas,
Right.
and the medical device manufacturers, and these are places where people's lives are there, but they're all building things on top of open source, but the analysis is not being shared, and it's I think they're all reliable. The FDA wants to know what's going on, for instance, and things like that, and they'll tell the FDA, and that's okay, fine, but if we're using these open source components, can we make it possible for people to actually get the higher quality levels going, to get, like, if you have a security fix, is your device still safe? Can we answer those questions? And so these are the areas that I think are a fun challenge and that we should be tackling as in the wider space.
Interesting. Well, what is Zephyr? You mentioned Zephyr. What is that exactly? It's
So-
been out for 6-7 years now, right?
Yeah, 8 years actually. And so Zephyr is an RTOS. The Linux kernel doesn't get smaller than 3 meg, okay, as an image size. And when you're working with sensors and actuators, you want something that's 8 to 10K and up. And you really only want the resources you actually need. So as we're starting to work towards being more sustainable, you really only want to use the resources you absolutely need. So having the flexibility to just configure in what you want to use and then build on that, it's a step towards creating products that can last for 5 years in the field on a battery charge. And we know we're knowing products with Zephyr that are in that sort of level.
Is it a system that allows you to take like the 3 meg kernel and carve out whatever you don't need and reassemble it into something you do, or is it?
So it's its own kernel. So it's not. There's no code in common with the Linux kernel. However,
Okay.
what they do is they have the technologies. So we've got device tree. So you have the abstraction of your peripherals and your components, and then you have kconfig, which is also a technology that the kernel pioneered. And you use these things to say, okay, when I'm building this image, this is exactly what I want in, and that's it. And so you have your basic kernel services, and that's your 8K. And so like a blinky type of light thing would be about that. But if you wanted to have a Bluetooth low energy stack on it, or if you wanted to have a Wi-Fi, these are all choices you can make when you're building your image, and then you just get what you need for those.
Interesting.
Yeah.
And there are products out there now that are using the Zephyr platform.
Yeah.
Right?
It's a discovery zone, okay? Because it's open source, they don't have to tell us. And the licensing terms on Zephyr are Apache 2, which again says you don't have to tell us you're using Zephyr. You should, give us some credit that's, the license by the license terms, but realistically, finding them is a bit of a discovery zone. And so it's a detective game to some. So I love when I learn about a new product.
It used to be, remember the license envelopes, and you had to get the discs and you had to
Yeah.
open the envelope, and somehow you agreed to the license and everything had to be on the envelope.
Yeah.
Of course, they don't do that anymore.
No, well, and that was their way of mitigating the risk, right? And there are certain things now that are replacing that. So things like software bill of materials or system bill of materials are a way of summarizing what is being used. Now, it's sort of, in the embedded space, shipping bombs with products has been around since, year dot, right? And so how do we, taking that concept where people were putting things together on the software side and not telling anyone, so the SBOMs are making that more transparent, which is, again, and some of the licensing terms need to be made transparent. So you're seeing evolution of that, and that transparency is going to help with the safety and the security. So it's a good move in the industry from my perspective to start to force things. And realistically, bodies like the FDA are mandating it now. And in Europe,
What are they mandating?
you have to have an SBOM when you basically
Okay.
give them a product to assess
Okay.
for before it's going into the market. That came into effect, I think, last year anyhow. And so they're looking to have that transparency happen automatically at scale. And then you also have in Europe the Cybersecurity Resilience Act, or CRA, is coming in, and there's going to be certain obligations associated with that, including this longer period of time of maintenance, right? Like this 10-year type of maintenance, or in certain areas longer. Cars have certain life cycles. All these devices have life cycles for maintainability. And when open source changes, like the Linux kernel changes at 9 commits an hour, okay?
Wow.
Zephyr is at 2.6 commits an hour. And so the question is, each of these commits is new features, new functionality. How do you reason whether there's a bug, do you pick up the fix or not? If there's a vulnerability, do you pick up the fix or not? Part of it's going to be, am I actually using it? Am I using that piece or that component? And so having the precision on the components, and then starting to evolve towards being able to say, which requirements are this code satisfying? So the whole software engineering side is one of those areas that, when someone's accepting a commit, there's always a reason. There's always a why. Why should I take this in? What's it going to do? Those are requirements. They're implicit requirements. They're not spelled out, but they are there. And open source is full of that. And the challenge is, well, okay, if you're taking this in, what do I need to test to prove that I've actually satisfied that and there's been no regression somewhere else? And so starting to shift things around so we can actually see that type of information is what we're trying to pioneer in Zephyr. And
it's an interesting problem, right? Because you aren't controlling the point releases and the major releases, and this is tested. It's been regression tested, and but it's a continuous.
Well, it's
releases,
continuous.
Right?
Like say, Zephyr, we actually have specific point release, but we do the backports of all the security fixes, like the Linux kernel's doing. We have LTSs, and our long-term stable. And so figuring out what we actually want to keep and what we want to test is fairly good. There's mechanisms for it. The issue is, for safety, you want to know that you still have not, if your requirements are still being satisfied after you've put that fix in, because you need that for the analysis of the safety principles, right? And so getting things so that we can start to share that analysis the way we're sharing code is something that I think is a fun challenge.
How is open source actually regression tested? I mean, it
depends on the project. Like I say, in the kernel, they've got the kernel CI and they throw a whole bunch of tests at it. Zephyr is also sort of throwing a whole bunch of tests at it, but it's not smart. And if we can start to get things to that requirement level, then we can sort of I think we'll improve the quality for everyone, which is important. And then, get it so that you can be more focused in your testing too.
The SBOM is interesting. I remember I had a DOS toolkit company back in the day, graphics toolkits. And one of the things we required was put our copyright on the in the manual. That was one way to check to see whether someone was using our stuff. We also embedded strings, of course, in the library so that you could actually search the exe and see, oh, well, there's our copyright, there's our code.
Yep.
But with a lot of obviously with embedded systems, you can't do anything like that. So it's like, how do you know what's under the hood? Does that ring or that device actually use Zephyr or not?
There's still cookie crumbs sitting in those binaries that when they're linked together and things like that.
If you can get to them, I mean, but you get the Aura ring. How do I know what's on here, right? It's like I don't even know how to get into it. It's just an amazing piece of technology. But
it is.
How do you just have to...
like trying to figure out what's actually running on this is my little, mission I've got right now. And that I'd love to talk to some of the developers of it just to understand what RTOS they're building it on.
Couldn't they self-register or something, or they just say hey, just add it to the list just so we kind of know what's going on?
Yeah, it'd be lovely if they would, but some of them consider it competitive advantage, so they don't bother, or they are resistant. One of the things that was interesting recently was learning that the Galaxy ring from Samsung is actually running Zephyr, and we found it out because of the Korean datasheet. The datasheet in English didn't say anything. The datasheet in French said some of it, but not all of it, and so forth. And so we were, trying to figure out, okay, which processor is running on it, which, RTOS is there, and what's all happening for, monitoring all these sensors and then conveying the information up to the phone. And so, given the fact that you want to have this to last a week before you have to charge it, roughly, okay, it's got to be pretty efficient. And that's where we're getting into the whole sustainable side, right? which is we want to be very efficient with our resources.
That's interesting because I know that in the past Samsung has rolled a lot of their own stuff, right? I think they had their own mobile OS, and I forgot the name of it now. But,
No, they've got NetX usually. I think they do. Actually, it's Tizen.
Tyson, yeah.
Yeah.
I think it was named something else even before
Yeah.
then, but yeah.
Yeah, and so it was interesting for us. Like I say, it's a detective game, right?
Mm-hmm.
And we were getting some of the Samsung developers in India submitting into the Zephyr Developer Summit. And we're going, okay, what are Samsung doing here? Okay, here are these people, they weren't talking about their products, but they're giving, talks that they wanted to give and to interact with the community. And so it's like, okay, interesting. Let's figure this one out. And we finally solved the mystery this summer. When we found out, these are the rings that they're going up with. It's sort of like that.
Well, do you think open source is better suited or worse for, building sustainable products?
I think because you're sharing a lot of the cost, it's better.
Mm-hmm.
I think most of the sharing of the common infrastructure and having the more eyes, you need a certain critical mass of a community. That's one of the things that the Linux Foundation has been studying is what is a sustainable community, what is a sustainable project, how do you actually build these projects to have best practices and so forth. But if you've got the community side and you've got the neutrality, the vendor neutrality, then you have a foundation where there's multiple eyes, multiple experts. You have people that come in and know what's going on. And so you can draw on a much wider pool of developers with different experiences because, it's pretty much accepted that, the more diverse your eyes are on the problem, the more likely to find when there's issues.
Is open source more hackable? I mean, the thing is, everything's there. Right?
Oh, everything
Yeah,
is there.
Mm-hmm.
And realistically, if we don't pay attention, there are things. The thing is, like with Zephyr, we had a journey, okay, on our security side, okay? So we had the CIA, or the open source, the best practices badge for security. And they started off with just a passing grade. So we worked out the project for 6 months, documented all the processes, got our passing grade. Okay, they added the criteria higher, a silver and a gold level. Oh, okay. So we started working as a project to do that. And, things like, things that would minimize risk. And so we sort of, got ourselves moving towards it. And we were sort of doing it right. And all of a sudden we stopped passing. I was like, what? What happened? And we had changed our infrastructure, and the regression testing on the links and everything else that we had put in said, hey, these don't work anymore. Okay, so by it testing automatically, it sort of sent a signal that, okay, this is worth taking seriously as far as I was concerned. So we went up to gold. And so we were the fifth project to do the gold best batches. But those practices, I think, set us on the stage for things. And any open source project can do it. But
This is gold level according to what?
Best practices badge. It's a gold badge.
Okay.
Okay.
And who's creating that badge?
It's it was created by the CII project. David Wheeler was very much involved in it, David A. Wheeler. And it's now under OpenSSF. So they're continuing to evolve it. They're also doing things like scorecards, which are sort of project security level work. And so figuring out these, open checklists and working down them and figuring out how you can get your project to conform to them. It takes a certain amount of desire on part of the community, but a certain amount of, you can't get gold unless if you were just a single person project, you couldn't get gold. Okay? So, there's criteria that, I think, the security people have figured out over the years as best practices. And so we did that in Zephyr, but after we got gold, we were figuring, we're good. And then someone paid NCC Group to do a security audit on us. And we got our first bulk vulnerability report. At that point in time, it was sort of like, oh, okay, I guess we've got more work to do. And so we adjusted some processes. And after the report, they were, like I say, they gave us a nice, we were good to work with. We did what we needed to do, et cetera. And so we sort of continued on, and we just came out with our last our LTS in July. And the project this time went to NCC Group and said, okay, can you find any issues this time now for us? And this time they only found some minor little things. So, trying to get the different eyes, different perspectives, we're taking it pretty seriously because, people are doing things that are important here.
As an entrepreneur, I know the importance of proactive legal advice. Hunton Andrews Kurth has been a leader for over 120 years, offering top-notch support in energy, finance, real estate, and retail. They handle problems like their own. Hunton Andrews Kurth, they get it done. And we're sitting down today with Frederic Desbiens, who is the Senior Manager of Embedded in IoT for the Eclipse Foundation. Thanks for joining me today, Frederic.
Thank you so much for having me.
Yeah. And you are from Ottawa.
Yeah. I lived there. Originally, I was from a region in Quebec, which is called the Saguenay region. So that's 200 kilometers north of Quebec City. So plenty of snow over there.
Well, I grew up in Minnesota, so I understand standing in a snowbank waiting for the bus that may never come.
Indeed. Better chance with a snowmobile.
Yeah, well, that's true. I do miss snowmobiling. All right, so what is the Eclipse Foundation? What do you do there? Sounds like something to do with the moon.
Yeah, well, it looks... well, most people still associate us with, the traditional desktop IDE of the same name that started in 2002. Or even 2001 from IBM, and then they created the foundation. But anyway, the Eclipse Foundation is an international nonprofit association. And what we do is stewarding open source projects. So everything that we do has something to do with open source. And initially, yes, it was just development tool. Then 2012, we started to diversify. I wasn't around at the time, I was told. But we started with our Eclipse IoT working group. And then over time, it expanded in various directions. And nowadays, we have a software-defined vehicle working group. We've got, of course, anything which is related to next-generation development tools like browser-based tools and things like that. We've got the full Java ecosystem now with the Eclipse Temuran virtual machine and, of course, Jakarta EE, the successor to Java Enterprise Edition. So plenty of things to like, but from an embedded and IoT perspective, there are really three main things that we've got right now. Eclipse IoT, still going strong after all those years. We've got the Sparkplug working group, which is about a very specific industrial automation protocol. And that one became an international standard, ISO IEC 20237, rolls off the tongue. We are really, really proud about that because, we're starting to build those bridges with standardization organizations. And the third thing is what we call the ThreadX Alliance. And the ThreadX Alliance is there to support the ThreadX real-time operating system, which was contributed to us by Microsoft in November of last year. And so essentially what it meant is that what was known as Azure IoT was becoming fully open source at the Eclipse Foundation and under the MIT license. So it's basically you do whatever you want. So all of those things are tied, let's say, in my domain, let's say, the foundation. And I have the great pleasure to work with all sorts of embedded and IoT people on really exciting things.
Why do you think Microsoft did that?
Well, I cannot try to fathom their internal thinking, but it was obvious, when they purchased ThreadX, because it was previously a proprietary product from Express Logic. So they bought Express Logic, acquiring the IP, the employees and everything. And I think the thinking was a bit of a follow-up act to what Amazon was trying to do with FreeRTOS, trying to tie a bit, the real-time OS to whatever they had in the cloud and using it as a kind of loss leader in a way to bring people to use more of their cloud thing. It didn't pan out so well for FreeRTOS. I mean, we could talk at length about them. I love them, but I wish they would be actually operating as a fully open source community, let's say. In the case of Azure, I think Microsoft realized that this was not bringing the kind of volume they wanted. And of course, they have internal metrics, so I guess it didn't pass muster. But the great thing that they did was instead of killing the product, because they could have simply killed it and two bad guys,
which happens all the time, right?
Yeah, especially from a number of web companies that are really adept at it and have even cemetery websites and all of that. Anyway, I digress. But so instead of killing it, they decided to contribute it to the Eclipse Foundation. And this is, I think, a manifestation of the good evolution at Microsoft in the last few years, in the sense that they became slowly more embedded, more participative, and more
less
understanding
closed.
Of open source. It's not a cancer anymore, And for that, we are really grateful, because without that contribution, we wouldn't have a first-class open source RTOS, which is the only one which is certified for safety critical applications in the market.
That's interesting. Yeah, there was a time when, of course, it was unknown. All of a sudden, Microsoft, with a lot of their revenue tied to Windows, is having to fend off all these free OSs like Linux, etc., right? And so they're like, yeah, no, open source bad. No one's paying for it, right?
Yeah.
So.
And this highlights one fundamental thing that we like to repeat at the Eclipse Foundation. It's about the value line. In due time, anything becomes a commodity. When I started my career, when I had hair on my head, believe me or not, but you were paying literally for every little development tool. You paid for the editor, you paid for the linker, you paid for the compiler, you paid for the macro assembler, you paid for this and that, and you were nickel and dimed in that way. And open source, starting with the GNU project back in the 80s, slowly transformed that. And we can be grateful for all of that great work that has been done. And nowadays, they estimate that between 80 and 90% of all the software in the world is open source.
Really? Is it that high now?
The thing is, even on an iPhone, which is something very closed and proprietary in its own way, you have tons of open source libraries lurking under the surface. If you go in the credits of your favorite game on your PS5, not sure if you're a gamer, I am, but I always look. Okay, they are forced by the licenses to give attribution to that, and you see this ton of libraries and all of that in the most surprising places popping up. So it's literally everywhere, and this means we need to undertake some kind of shift, in the sense that up to now it's been pretty much, we take and we just take advantage of that. But if you want to create a more sustainable economy worldwide, we need to properly sustain open source projects and initiatives, in the sense that if you don't give something back, whether it's a bit of developer time, a bit of documentation, promotion for a specific project, or any of those things, ultimately you are in a way forcing the market to reinvent the wheel instead of supporting what's already there and has been proven. So from a sustainability perspective for the whole IT industry, and especially for the embedded and IoT market, open source is key, because we want to innovate on top. This is what would get you sales if you're thinking about running a company or setting up a new one. So if you spend time reinventing the wheel, writing a TCP stack and an HTTP client, and you feel it's so good because I'm such a great developer, you're wasting your time.
How do you balance that? Most companies are worried about losing a competitive edge by open sourcing whatever it is that they've innovated on.
Yeah.
Right? And so that's why they've taken advantage of the open source, and then they add their proprietary stuff on top, so they don't have to recreate it, they don't have to re-release it, right?
And I'm perfectly fine with it in a sense. We have several members that do just that will have a very healthy open source project as the core, and then they will have plugins, extensions, specific things that you will find only in their commercial products. And that's fine, because of course you need sales to pay your membership to a foundation like us to keep the lights on. So, I'm happy that they get sales. But at the same time, there's a point where the value line goes up. And what was innovative 20 years ago is now run-of-the-mill, so to speak. HTTP client, really exciting to get that in an RTOS in 96. Nowadays, if you don't have it, you're not in the game. And it's even a bit laughable to put that on the spec sheet in the sense that it's yet another checkbox, but no competitive advantage comes out of that. The same with MQTT. Really exciting to get in 2005. Nowadays, you gotta have it, but the thing is, the world doesn't need 30, 40, 50 different MQTT clients, even in the embedded space. Just keep the bunch, the handful of them which are really good, and improve that and optimize them. Don't reinvent the wheel. So from that perspective, it's great that some people will pick that up. But the thing is, you need to give something back. And that commercial success that you are looking for is enabled by all of those open source technologies. So if you don't have this civic reflex of giving back in one way, then you're missing out. But then I would argue that even from a business perspective, you're missing out if you don't give back because, well, open source, it's great. The code is there. There's no obligations. There's no license fee and none of that. Wonderful. But what happens if you have a critical bug on a Friday night? It's open source. No one is forced to give you support or try to fix it overnight for you. Well, the game is a bit different if you're part of the community. And that's the thing. It's the relationship that you create with the other stakeholders for that particular piece of code. When you create it, then someone maybe will look into it overnight for you because you've been around when they were in need and you've been participating. And I think increasingly, many organizations are starting to get that, which means we have unlikely members at the Eclipse Foundation that you wouldn't have expected in the open source game. Companies, in my case, on the Sparkplug working group, we've got Chevron. Okay, they care deeply about that piece of technology. They want to have their voice heard around the table when there are evolutions to it. And they want to tell their suppliers, hey, look at the official compatibility page on the Eclipse website. We buy from there. Okay, so there's a big advantage for them from a commercial perspective. And at the same time, there's a big advantage to us because, well, having end users like that changes the game. It's not just a bunch of open source geeks in a dark room. We have a bit more friends.
Like it was at one point.
And it was at one point. That's the thing. That's always the danger in any industry, right? You're comfortable in your own echo chamber, and then you don't realize that the world changed around you. So having people like that, changes the game. And I singled out Chevron because I worked with them, on a bi-weekly basis on our steering committee calls. But, there are many other examples, like Mercedes is a strategic member of the Eclipse Foundation because there are so many things, and not just in the software-defined vehicle working group, but also in our brand new regulatory compliance working group, something that we set up because in order to face new regulations in Europe, particularly, we needed a way to have specifications and standardized processes to address that, to ensure that companies can more easily be compliant to that. And so Mercedes is also, a big contributor on that side of things because they believe in the open approach now. And when one gets in, well, typically the others follow. So I'm hopeful. Well, we have already a bunch of other car makers like Cariad, the software branch of the Volkswagen Group, and Harman and Cummins, and all of those players in SDV. That's not my domain, but that's another good example of non-traditional companies that really get it. And on the Java side, we have companies in finance services that rely a lot on that for day trading and things like that, and they invest in our Temuran virtual machine. So you see it pop it here and there. And it is my expectation that it will really transform the whole of society at some point because software now is everywhere.
Mm-hmm. Well, I'm a big believer in give first, but I also know, for example, I always felt for a while when you're searching the internet and you're looking for an answer and, I know some things, right? And how many times it's like, well, the answer is there, right? Like, okay, I want to contribute to message, but I feel like I'm consuming, from Stack Overflow, et cetera, right? But then there were never really opportunities to really provide an answer because the answer was already given, 10 times over. But in open source, I can see that could also be an issue, right? Where you are consuming, but it's like, well, I'm not actually, I want to give back, but it's, there's lots of people already working on this solution. But how do you encourage companies like that to to get actively involved. And if it's a big company like a Chevron or a Mercedes, does that really upset the balance? You have these big gorillas working in these tools and wanting to do things their way, right?
Well, that's a potential risk. And there are various ways to, let's say, achieve a level playing field, or at least to create an ecosystem where everyone is welcome. So I won't comment on the way that other players in the space would do this, but we feel at Eclipse that we've got the right formula for that. And essentially it lies into this. First, anyone can start an Eclipse open source project without even being a member of the foundation. Tomorrow morning, you want to contribute a piece of code and start, organizing a community around it. Well, you can do it. And from that perspective, the barrier to entry to contribution is very low, because the one thing that you need to do to contribute a new piece of code or a piece of documentation to be merged in a repo somewhere is to sign our electronic contributor agreement. And what the contributor agreement says is it's not even a copyright transfer or anything that would deprive you from your rights. It's literally just saying, I give to the Eclipse Foundation a license to my contribution. That's all it says. And of course, our lawyers would argue differently, but the TLDR version of this is simply that you give us a license to it. And so from that perspective, you find a project that you care about, and of course about which you are knowledgeable, and start thinking. I mean, you have pain points in your daily use of that library. What could I fix? What would I improve? But of course, what I would recommend is not to blindly start banning thousands of lines of code on your keyboard. Engage with the guys who are already there, right? Discuss over the mailing list, or we have, Slack workspaces or channels that are more interactive. Engage with the existing people maintaining this. Discuss your ideas ahead. They will give you a bit of feedback, and you slowly integrate the ecosystem in that way, in a very deliberate way. Now, the one way we have at Eclipse to distinguish between, employees from big corporations versus, a new head start developer from a small startup, well, it's simply that every contributor to an Eclipse project is there as himself. So, of course, we track for paperwork purposes, we track the corporate affiliations of people, because when you're part of a big Eclipse Foundation members, you don't need to sign as many agreements. Your company already signed a bunch of them. But essentially, from a project perspective, your employer doesn't count. An Eclipse project is the property of its project leads and its committers and contributors. And essentially, we hold the trademarks and IP on behalf of the community to ensure nobody runs with it and, makes money on the back of the community. But apart from that, it's about them setting their technology vision, and we just have the governance layer, the processes that will maintain this level playing field. Where corporations come into play is what we call our working groups. And they are completely decoupled from projects. So this is different than what you would see at the Eclipse, the Linux Foundation, for example, because in their case, it's always together. That's why they have, those boards which are distinct from the technical committees driving. In our case, those concepts are completely separate. So the big corporations have a seat at the steering committee of the working group, and they get to decide where the marketing money goes and, the general vision and things like that, how outreach is structured about the project. But even then, when we have an Eclipse working group, the charter says what the fees are, and it's always a fee schedule which is calculated according to the worldwide annual revenue of the organization, which means a large organization will pay $250K to be around, in US dollars or euros, whereas a startup could get in for as little as 1.5K or 5K, depending on the nature of the working group. And so when that happens, you have two people on the steering committee. One is from Mercedes, the other is from Friendly Startup, and they still have a single vote on each side. Independently of how many committers they have in employ working on projects, independently of the size of the company, and they can have literally exert the same level of influence, up to a point, of course. And then, well, if you're a startup, it's up to you to be clever and bring value to the group so that you drive them and not are driven by them. So the way that we operate, we feel, is really favorable to those really small organizations, because really, yes, we have a place at the table for the big players. They bring the big money. That's good. But then, the startups often bring the actual innovation. And many of our projects have been started by small startups that grew along the way, and it's a delight to see them succeed.
Interesting. At SoftTech, we don't just follow the trends, we set them. As the founder and CEO, I've built a team that excels in delivering cutting-edge solutions in software, hardware, and IoT. From concept to completion, we're the partner that turns your tech dreams into reality. SoftTech, where innovation starts. And we're sitting down today with Gulroz Singh, who is an SoC safety architect. Hey, Gulroz.
Hi.
Thanks for coming on the show today.
Thanks for having me.
So what is SoC? It's system on a chip, right? So what does that mean to be an architect on SoC?
So a system on chip is all about having compute power on hardware. So we are talking about, cores. We're having CPU power on the chip along with peripherals like memory, your networking devices, all that on the single chip. That's why we call it an SoC. And being an architect for an SoC is really about making conscious decision about the performance needs for a device, or the safety requirements for a device, or the security requirements for the device. So we really come in the concept phase of a device, and we try to clearly write the requirements and create an architecture for the device.
Okay. So do you do that? I mean, so is NXP wanting to do the SoC, or is it like a client comes to you and they have a particular need and you need to design the SoC, the system?
So we have off-the-shelf products, and we are in the business of creating SoCs for automotive industrial markets. So we typically have a leading product from a leading customer, and then we have variants for a product as well.
And the SoC allows you to group a bunch of related parts together all on one chip, essentially, right?
Exactly. So with the growing demands for high performance, with AI ML software being on the chip, you want to have more and more compute power. And that's where the SoCs come into the picture, where they allow you to have multiple cores, multiple CPUs on a single device.
And then that's faster and
more
efficient.
Power, more efficient. You can have multiple applications running on a single chip, which is what our customers want and need. And that's what we're forward looking as well.
And the automotive industry in particular needs a lot of this type of work done?
Recently, with the advancement in EVs and autonomous driving, self-driving cars, we are always looking at more and more compute power and also AI ML applications running. We also have this concept of software-defined vehicles, where the normal functions of the car are being realized by software now. So more and more things are being put on the software, and that's where we want multiple applications running on a single device, single SoC. And that's where, the needs for more compute power are coming into the automotive industry as well.
I mean, there's talk about edge AI and AIoT. Is it hype or is it real?
I think it is real because most of our customers are deploying it in the real world, and we see that. We have real world requirements on AI, ML, edge, AI, and IoT stuff coming in as well. So a lot of the safety requirements that were originally in automotive world are also being trickled down to the let's say IoT or industrial devices as well.
What would be like an example of a safety application where the SoC is handling that?
Could be anywhere from the powertrain of the car, so electric drivetrain or powertrain of the car, to the infotainment system, to the cluster that you see as a driver on the monitor. So as simple as that to the high-end stuff like controlling the braking system of your car. So everything involves an SoC device. and that's where safety requirements are assigned to a particular device.
And really, I guess in a car or an EV, almost everything has a safety layer on top. Is that what they're trying to accomplish?
Definitely when we talk about more and more functionality in the software and moving away from the mechanical parts, you want to make sure that the software is running correctly, the cores, the CPUs are computing the software correctly, and that's where you have pretty much all the devices in automotive these days having a particular ASIL level. We call it ASIL level because of the criticality. So ASIL B would be less critical than ASIL D, and we have different kinds of devices in the market as well.
Are there different levels of certification involved in that?
Definitely, yes. So ASIL B is much less, let's say, less effort in terms of putting in an architecture for an ASIL B device versus an ASIL D device, which probably is used for braking or powertrain or critical functionality of a vehicle.
But how do you architect safety into something like that?
Yeah, so I mean, architecture-wise, you're always looking for critical components having either redundancy, diversity. So if I have a core, I might want to have another core that's checking that core. So typical redundancy or diversity. You might want to have things like ECC in the memory. That's pretty, or error correcting codes anywhere around the data path of the device. So just making sure you have those checks, fault detection checks across the device.
Is it more than just redundancy, or are you actually double checking?
Redundancy is the easiest solution. As a safety architect, if I have the room to have everything redundant, I can make everything redundant. But that's the easy solution. The harder solution is having that confidence in the hardware by having certain fault injection mechanisms, certain fault detection mechanisms, and then using software on top of it to check the hardware as well. So you can use leverage software to sometimes check the hardware and stuff like that.
And of course, a famous recent example of not having redundancy is the Boeing, right, 737, yes, where it had like one air speed sensor or something like that.
Something like that, yeah.
Where if that one sensor fails or it's getting bad data, then that's bad.
Right.
It's hard to imagine that actually got to production that way, but in the case of a car, it's similar, right? You don't want your runaway, acceleration or your brakes not to work because a lot of things are less and less mechanical and more digital.
Yeah, with the aviation industry, they have the room, and even from a cost perspective, they can put multiple redundant items, a VRU, an ECU, 5 times or 3 times or 4 times. We call it triple modular redundancy because they have that cost structure and even the size. But in automotive industry, we are dealing with less cost margins, very critical functionality as well. So you want to find things in the same device, make certain things that are critical redundant maybe, and then the less critical things not redundant.
I remember that because I've been in this industry so long, but there's always a running joke about, well, of course Microsoft can't make cars because you had the blue screen of death and you had crashes and the Windows operating system and everything. But now the reality is these cars do have a lot of hardware and software in them, and yes, a blue screen of death would be very bad in a car situation. Right?
100%. I think that's where we differentiate between safety critical devices and non-safety critical devices. If your laptop stops working, most probably it's not going to kill anyone. But if your car computer stops working, you might be in a situation where a pedestrian can be harmed or you can be harmed as a driver.
Mm-hmm.
So we want to make sure that the products are developed according to the safety criticality of the application, keeping that in mind. And that's where, the aviation, automotive, and industrial equipment industry is slightly away from how the consumer electronics are created.
I don't know. Sometimes I feel like killing someone when my laptop crashes. So maybe share some insights on what you see as the future of automotive safety.
I think with the advent of, again, autonomous vehicles and more software in the vehicle, along with the electric architecture now in the EVs, we see that this trend of more and more functionality being put on multiple ECUs. So one ECU can handle multiple applications now. So I can have really a single SoC device maybe running 5 different applications with different safety criticality. one might be just QM, so just quality managed application. Another one would be really highly safety critical. So for a device to manage both those applications in a safe way, that's where the challenges come in the future, where we want to make sure that different applications, first of all, do not interfere with each other, do not corrupt each other. If one goes bad, the other one doesn't go bad. And then we also detect and report faults for that application. So you're just controlling that application. A lot of times we see in automotive that different software stacks are created by different companies, and you don't want them to be interfering with each other. And I see a challenge there. And I think at NXP we have tried to figure out a way where we allow to the applications to not interfere with each other by having specific hardware mechanisms on the SoCs. And I think that's going to be more and more critical going forward.
So you're essentially kind of trying to keep multiple applications or even drivers in their own almost sandbox in a way.
Exactly.
So like a driver just doesn't, like in the case of Windows, a driver can crash the whole thing or lock up the whole thing because it's, they're interfering with each other.
Exactly.
Mm-hmm.
Yeah, a good example I give that is sometimes is if your infotainment system stops working, your car shouldn't stop working.
Yeah.
Right. So I can go without an FM or the music, but I still want to drive my car. So that's a good example. And a lot of times the infotainment application and let's say the steering application probably is running on the same ECU. So you want to make sure they don't interfere with each other.
I mean, there's going to be more and more complexity with, not just EVs, but self-driving cars, right?
Yes.
Can they get more complex and be safer at the same time?
That's where the challenge is, because you have a lot more of these AI ML accelerators on these SoC devices, and you want to make sure they are safety compliant as well. And we want to do that without redundancy. So redundancy is an easy solution, but much more expensive because it takes area, it takes more power, and we want to go away from that. So that's where a lot of scope of innovation is, where you want to make sure that these complex AI ML accelerators are also safety compliant and security compliant and stuff like that.
Yeah, I guess it's like putting an AI in charge of the gas pedal. You might have the reliability of the gas pedal working properly, but now the AI is a terrible driver.
Exactly.
Right? Although I think in reality what's going to happen is that cars are going to be safer because as far as what I've seen on the roads, most people don't know how to drive. I think the AI is actually going to be better at driving. And then also, if we do get it to a point to where there's some type of mesh network where it knows what's happening a half a mile down the road, so you go over a hill and the cars are stopped, it already knows they're stopped, right? You don't actually have to see that they're stopped.
Right.
And I'm looking forward to just being able to get in the car and go to work while I continue to do whatever it is I want to do, either emails or etc. Because most of the time boring just isn't that interesting. I mean, most of the time driving is just not all that interesting.
100%, right? Especially in Austin.
Yeah, Austin, Houston, etc. Well, that's interesting. Well, how do the functional safety standards, how do they continue to evolve, right, to maintain this, safe environment?
Right. So one of the major functional safety standards in the automotive industry is ISO 26262. And we have applied that standard for the last maybe 10, 12 years successfully across our devices. But what we also see is that there are AI safety standards evolving in the automotive industry. And they might be something that we want to look at in the future. At the same time, we also have security standards in the automotive industry. There's a standard from ISO called ISO 21434. And that is applicable throughout the automotive stack. So starting from OEMs to tier ones to semiconductor world. And I think that's where you would probably see a lot more innovation, just meeting that standard with the high performance stuff on top of it.
And is that safety related, as far as hackability? I mean, you see a lot of news stories about people being able to unlock cars and turn on cameras and things like that. I mean, obviously, someone hacking your car is a bad thing.
100%. So I think that's where the security piece fits in. You want to make sure that your devices are secure enough, and the intruders, the third-party intruders or hackers, they don't have access to critical pieces of information from the device. And as we see high performance, we want to see things like automotive Ethernet. So networking, high-speed networking, real-time networking. And with all of these communication protocols, there's always room for hacking and intruders attacking these protocols. Maybe it's just a simple denial of service attack, but if it's a denial of service for a steering application or a braking application, that becomes deadly.
Mm-hmm.
So a lot of times people say, oh, denial of service is just like, oh, my thing is switched off. But if it's a critical application, it still can be really harmful to the driver or the pedestrian. So you want to make sure that the security and the safety go together, even from a semiconductor point of view.
And so does the industry have to collaborate with some of these regulators and standard bodies?
We definitely have, representatives from across this automotive stack in these standardization bodies. We see our OEMs, tier 1s and tier 2s participating in these standardization bodies. So I think it's definitely going in the right direction. We also see, even in our organization, we collaborate between the safety and the security folks, because, safety can sometimes say, I want everything redundant, but that also increases the attack surface area for an attacker to attack the device. So that's where the security might contradict the safety piece. And you want to make sure that, you're walking together the same path of being more secure and safe.
How far are we really away from self-driving?
I think like any technology that we've seen in the past, we will continue to evolve and get better with self-driving cars and autonomous driving. But I think for the near term, we should focus more on ADAS, so more on advanced driver assist systems than full self-driving. I think ADAS is much more realistic than self-driving or pure self-driving cars. And I think the industry is starting to realize that in the last 2-3 years, that ADAS applications are making drivers safe now, versus the self-driving or the autonomous complete autonomy might be a few years later from now. Yeah.
How hard is it really for like a startup to break into, say, automotive or EV? You have any perspective on that?
I think it really depends on what space you're playing in. With the evolving vehicle architecture, so EV, of course, you want to move towards zonal architecture, software-defined vehicles. There's definitely this piece where a lot of startups can play in terms of software integration. So we have these all new complex devices, networking devices. They're all talking through Ethernet, CAN, or something like that. And there's always space for providers who can integrate these high-performance devices together. So I think that's where maybe you'll see in the future as well a lot more startups popping up and provide services to OEMs and tier 1s.
Anything else that you're excited about in the next 10 years?
I think the making autonomy safe is definitely something that in the automotive industry people are looking forward to. Right now we're not there yet, but I think I'm really excited to see when we actually see an autonomous car being safe, 100% reliable, and passing all the safety and security certifications.
Are we going to have steering wheels 10 years from now?
Yeah, that's a good question, but I don't have an answer to that.
I can see maybe not. I mean, for some cars, right? It's like there might become a time where 16-year-olds aren't looking forward to, they don't need to drive. I mean, nowadays it's like probably safer to give them maybe not safer. Is it safer to give them an Uber app where they can go get rides with strangers? In my day that was not a good thing, but if you're keeping them from driving a couple of years longer, there's a lot of stats about that, right?
Right.
So the longer that they take before they start driving, the safer they are.
Mm-hmm.
But at some point, if they can just take your car and go, right?
Mm-hmm.
They're not driving, but the car is driving. You want to go to
Right.
the mall, get in the car and go to the mall.
Yes.
Yeah, very interesting. Well, Gulroz, thanks for coming on the show. It's super interesting stuff. I'm really looking forward to what you're going to create here with NXP and in the world of EVs. Please keep us safe.
Thank you. Thanks for having me. It was a most pleasure.
Sure.